Adhesive forces. What causes them? Polarization, electron placement, electrostatic forces, mechanical forces. Actually, all these things can cause things to stick to one another. Electrostatic forces and polarization are magnetic forces. One side has a positive charge and one side has a negative charge in water. The hydrogen is charged negatively, so positive particles or molecules will stick to them. But the oxygen is charged positively, so negative molecules will stick to them. Now, it doesn't matter if the entire molecule is neutral. That means the total amount of electrons and protons are the same, 10 and 10. I mean, it just matters that one side is positive and one side is negative. Mechanical forces and electron placement are other things that can have an effect on adhesion. Mechanical forces are forces that act on objects by direct contact. We'll talk about mechanical forces some other time. Water is polar, meaning that it's positively and negatively charged. So, water has quite a bit of adhesion. Now, adhesion and dissolving go hand in hand. See? When something dissolves, the molecule and the solid break up and join the molecules with the liquid. Now, something won't dissolve if it's not willing to break bonds and join up with the liquid molecules. Or, in other words, the cohesive forces are stronger than its adhesive forces. Or basically, the solid wants to stick to molecules of its own and not the liquid's molecules. Anyways, things can dissolve very fast in hot water because when heat is added, the molecular movement increases. And the space between the molecules increases. It gives more space for salt and other molecules to bond with water molecules. By the way, dissolving is a physical change because you can separate the liquid and the solid. Watch. Notice that only the salt is left. That's because of evaporation. If an object is a liquid at room temperature, it probably has a higher evaporating point than the solids. Oh, hi, carbon dioxide. Carbon dioxide is nonpolar, even though oxygen has negative charges and carbon has positive charges, as you can see in this crudely drawn diagram again. Now, that's because it's a linear molecule, meaning that the bonds form a straight line. Now, onto magnets. See, magnets always have a positive side and a negative side, even if you break it apart. They always have a positive and negative side. Now, carbon dioxide only has two negative sides, so it's not a magnet. Okay, good. Problem solved. Well, we'll talk a little more about carbon dioxide. You see, the oxygen has an outer shell with 6 electrons. However, it wants to fill its outer shell to 8 electrons. So, it takes 2 electrons from carbon. Both oxygens take 2 electrons from carbon. Alright, great. I'm gonna go outside. Okay. Okay, man. Okay. Oh, look. Snow. Snow is formed when a liquid molecule condenses around a particle. So is rain. However, hail is when there's no particle and it's just ice. And then sleet is a combination between rain and snow. Alright, great. Is this it? Yeah, okay.